Okay, so now I want to make a little interlude and introduce a very new teaching technique, which is new for this year, and I hope it will be fun. I want to talk to you about two very basic electrical engineering concepts, and this is the open circuit and the closed circuit, the short circuit. So this is a short circuit. So it's a base. It's like a resistor with resistance of 0, and current really loves to travel through this short circuit. It loves doing it because there's actually no resistance. And another thing I want to show you is the open circuit. An open circuit is a bit of wire which I just cut a bit out of it. And this circuit element is the power really hates to electrons really hate going through it because it's very hard for them. It's impossible for them to go through the open circuit. Okay, so this is an open circuit and a closed circuit. Yeah, and there you go. Okay. So now I want to take this circuit and let's do some kind of practice modifications. And I'm going to take the circuit and I'm going to do like this. And I'm going to do, yep. And this I'm going to cut. Did I get the white pen? Can I get the white pen in this thing? Yeah. Okay. So now I'm going to turn on the shared whiteboard. And I want you to imagine that you are electrons and go through VDD to ground and tell me how you're going to kind of just draw how you're going from VDD to ground in this circuit. So this is beautiful to see. So yeah, you're all going through the short circuit with no problem. Wonderful. Okay, so thank you. Can I undo? No, I can't undo. This is cool. I can't. Oh, now I can. Great. So now I'm going to do something else. I'm going to do an open circuit. So I'm going to cut the circuit again here, and I'm going to make an open circuit here and here. And now, what are we going to do as electrons? So you're not going to move at all, basically, because there is no incentive for you to go. You're not the current has to flow because this is stuff. You're not actually going to go into the load because there's nowhere to go. So actually okay. So how do they know? Who knows? I don't know. Maybe the angels tell them. I don't know. So it's also all the electrons stay and they don't want to go to the. This is a voltage divider, and it's kind of what I showed you is kind of simplistic. Now let's do something a little more complicated. And now I'm going to do what is called a current divider. And a current divider, I'm going to take this circuit and I'm going to make a nice junction here and junction here. And I'm going to take and put my open circuit here. So now the current has two ways of going from VDD to ground. It could either go through the load or go through the open circuit. Now, please tell me show me what the electrons are going to do. Yeah, okay, they're all going to go through the load. Lovely. Now, what is going to be the current going through the open circuit right now? What is the current? Of course, 0 amperes. There is going to be no current because the electrons don't want to go. It's very hard to go through here. They're all going to go through here. Lovely. What is going to be the voltage difference between here and here? This is a little more difficult to answer. What is going to be the voltage difference? Okay, so Bido says VDD. Indeed, the answer is VDD, or I times R, and that is because this point is at the same potential as the ground, and this point is at the same potential as VDD. Lovely. This is wonderful. Now, and now I'm going to do the last thing. I'm going to connect a short circuit in parallel with my circuit. And now, please, my electrons, show me how you're going to flow this time. Okay. Everybody is going to go through the short circuit. Resistance is 0. Yeah, right. So what is happening now? What is happening now is that the electrons have two options. They can either go through the load, which is it's a load. Yeah, it's not so little, but it's a load. Or they can go through the short circuit, which is really easy for them to go. Okay, so we're agreed. Our distributed computation discovered that all the electrons want to go through the short circuit. Now, what is the voltage drop across the short circuit? Zero. Zero? This is VDD and this is ground. It's going to be VDD? It's going to be VDD. This is VDD. Okay, so by Ohm's law, the resistance is 0 and the voltage is VDD. What is going to be the current? What is going to be the current? Okay, the current is going to be very, very high. The current is going to be very, very high. And what is going to happen? Somebody who actually tried this, yeah. So we're going to have a very nasty smell. We're going to have fire. And what happens is that this short circuit, it's not ideal. We're not in an ideal world. It's going to get all this. It's going to do some work. This work is thermal work, and it's going to heat up more and more, and it's going to melt the insulator, the plastic insulators. It's going to get this very, very bad smell. And you're going to get corona. I don't think so. But what you can also see here is that the device you're trying the load here is not going to get any kind of electricity supply. It's not going to get anything because all of the electrons are going through the short circuit. Fine. Now, thank you. You are excellent. Thank you for participating in this new teaching technique, distributed electrons. Now, I'm an attacker. This is an attack course, and my objective is to measure the power consumption of the device under test. This is my victim. I want to measure the power consumption. This is what I'm going to do, and I'm going to get all sorts of secrets out of that later. So, my tool is indeed what OL says is a measurement device called an ampermeter. And an ampermeter looks like this. It's a circle with the letter A in the middle. I wonder if I can. Yeah. I was hoping that I can. Okay, so I'm going to draw myself, and good luck to you. Yeah, this is the letter A. Yeah. Okay, this is an ampermeter. And the ampermeter is measuring the current which is going through it. How does this help me to measure the power consumption of the device? Well, the ampermeter, by design, has a very, very small resistance, nearly 0. So what I'm going to do is I'm going to take my circuit. I'm going to cut the cable between the VCC and the ground. And you'll see some pictures later today. And I'm going to connect my ampermeter in serial to the circuit. And now this is a voltage divider. So if you do a voltage divider with a short circuit, will I have any effect on the, will this change the voltage drop on the load? Will the voltage drop on the load change because what I did now? So the answer is indeed No, it will not change. Why won't it change? Because this is like a short circuit. I just showed you a short circuit. It doesn't change anything. So the voltage drop doesn't change, the current doesn't change, and I measured the current. And because I have now I, and because the voltage drop doesn't change, I also have V, I can multiply I by V, and now I can get the power consumption of the load. And this is how we do power analysis. You cut the device, you put the probe in parallel, and you get the power consumption. Now, you go to your systems engineer, and you tell the systems engineer, listen, if you cut the device and you put an ampermeter in series, then you can get a lot of secrets. What does your systems architect tell you? What does it tell you? Yeah, it tells you, why are you close to me? You need to stay 2 meters away from me. You say, yeah, you will say, so what? It says it's outside the threat model of the device. It's very invasive. It's invasive. You need to cut things. We have a camera pointed at the device. We inspect it every 24 hours. Nobody's going to be cutting anything here. So let's try to do something less invasive. So I have a suggestion. So I'm going to try and doing this in parallel with the, where is my, I have an eraser in this? I can only do this. Okay, I'm going to put this in parallel. So I'm going to take the device, I'm going to take the ampermeter, and I'm not going to cut anything. I'm going to do this. Non-invasive, very good. Will this work? What will happen now if I connect the ampermeter in parallel with the, so just as I showed, this is the current divider, and right, this is a current divider. It won't work. So I have to be connected in series. So as far as power analysis is concerned, unless you do some kind of tricky stuff, which there is a lot of tricky stuff, but the basic power analysis is invasive. In some cases, it's legitimate to be invasive. If you have the device in your possession, you know, a smart card, a phone, a payment card, and so on, you can be invasive. But sometimes it's less. So this is how you measure power. You measure it like this. You put an ampermeter in series. And now just a little detail. Ampermeters are another way to build an ampermeter is to take a very sensitive voltmeter. A voltmeter is something that measures voltage, and it's designed to have a very high resistance, like an infinite. It's like an open circuit. So what I'm going to do is going to take a voltmeter, and I'll show you. I'm going to take this. I'm going to cut the circuit here, and I'm going to make the following circuit. I'm going to take. Let's go over here. I'm going to put my voltmeter here. But if I put it like this, then the system will be this. Now this is an open circuit again, so nothing will work. So I'm going to take a very, very small resistor here, like a tiny resistor, maybe 1 ohm, and put it in parallel. And if you think about what I did right now, if this is a very, very small resistor, then it won't have a lot of effect on the circuit, but there will still be some voltage drop, and I will be able to measure that using the voltmeter. So this is how I effectively am going to build an ampermeter out of a voltmeter. And you'll see something like that in a couple of slides later. So now let's make